All right, folks, I'm really excited to start our webinar off by showing you one of my favorite enhancements to SOLIDWORKS simulation. In fact, it's probably one of the best enhancements I've seen to SOLIDWORKS simulation since 2015. It's been a while, right? This has to do with something called Topology Study. And think of it as like a FEA on steroids. Basically, you're asking SOLIDWORKS to come up with the most ideal shape for a particular component. In this example here, I want to redesign this housing that holds up our flywheel in this motor assembly. Now you can see it's a pretty traditional shape, very prismatic, nothing very exciting. A lot of probably unnecessary material that we could get rid of. So Topology Study is going to allow us the ability to set some boundary conditions, apply some constraints as far as how stiff we want it to be and so on, and SOLIDWORKS will take care of the rest for us. Now, you don't need to be intimidated by a topology study because it's very similar to a normal SOLIDWORKS simulation study. You have your bodies that you're going to apply the topology study to. You have your loads and restraints. But this is the new categories to consider. So under goals and constraints, you have the ability to right-click that and choose different strategies. You can choose to have the best stiffness to weight ratio. That's the default. You can just minimize the maximum displacement, minimize the mass, and then of course go to the details of those. In our case, we're going to try to reduce the mass by at least 70%. We want to make sure that we have our first mode of natural frequency above 150 hertz. We basically want to avoid the resonant frequency of the motor that is supported by this bracket. Then there's some other really cool time-saving features like a symmetry control. So this is one of the manufacturing controls. Essentially what we have here is the ability to cut the model in half because it is symmetric, and it's essentially, it's not quite loaded symmetrically, but it is geometrically symmetric, so we can use that. We also want to make sure that during the design, we don't have anything less than a 20 millimeter wall thickness, because if we were to shoot this with a plastic injection mold, we want to make sure we have at least that much material in our wall thickness. Of course, the mesh is something you do just like you do with any other SOLIDWORKS simulation study, and then you run the results. Now I'm going to take a look at the material mass result here. What you're looking at right now is basically the ideal shape that would meet all the requirements of our goals and constraints. So this has basically met the requirement to reduce the weight by 70%, and we are going to have at least a 150 hertz or higher frequency. If you right-click the results folder, you can look at the actual resonant frequencies right here, and you can see that our first mode is 150.13, cutting it pretty close. But a good question to ask is, how many iterations did it take to get to this ideal design? If you right-click the results folder, there's a View Convergence Data and Graphs plot here. Now, if you look here, you'll see that there is a constraint for, again, stiffness. We talked about that earlier, and mass. And we wanted to keep it above 150 hertz as far as resonant frequency. So as far as stiffness goes, let's take a look at the graph. This is really cool data, of course, because it showed that SOLIDWORKS considered several designs. It went to the point of 43 iterations before it hit its goal. So at one point, it was quite stiff, but to meet the other criteria, it had to compromise. Now, when you have all this data said and done, what can you do with this shape? Okay, this is where it really gets exciting. This is a pretty organic shape. Trying to design this with lofts and surfaces and all that kind of stuff would be pretty challenging. So you have the ability to export that shape. What you want to do is right-click the plot and then choose the Export Smooth Mesh option. I love this because I'm a terrible designer in SOLIDWORKS, actually. I can't think of really sexy shapes. Just make pretty prismatic shapes. Let SOLIDWORKS do all the hard work for you. And then once you get that ideal shape, you can choose to either make that exported shape a part of the current active configuration, a new configuration, or better yet, its own file. And you can save that out again to its own directory and so on. You can choose to save just the graphics or the solid body. I recommend you do the solid body. That way you can start to form it a little bit better, make it a little clean, basically detail it enough for manufacturing. So again, one of my favorite enhancements. And I'm sure you're gonna have a lot of questions about this, so please make sure you fill out the QA card here in the webinar and ask me, and I'll gladly answer at the end of the webinar.